Hey everyone, welcome to another session of CeerazzleDazzlePhysics. In today's session, guys, we're going to be talking about Kirchhoff's first law. So put down today's title, it's going to be Kirchhoff's first law. And before we get going, guys, make sure you hit the like and subscribe button to keep my channel going and keep my content as free as possible. Share it with anyone who's actually doing physics right now. Okay, so let's get straight into it. What exactly is Kirchhoff's first law? Okay, so before we get going, we're going to have a quick recap on how current behaves in series and parallel circuits. Right, so the best way to talk about this, I always talk about it in terms of cars and cars on a road. So let's just say this is a road over here, and we have 10 cars on this road, yeah? We've got 10 cars going down this road, yeah? 10 cars going down this road, and then the road splits. And I say to you, all right then, 2 cars take this route over here. The question will be the following. How many cars go down this route? How many cars will it be? Well, guys, basic logic. You know 10 go in, 2 go down here. Well, this one will be obviously going to be 8, everyone, yeah? So this one will be 8 cars over here. Obviously because 8 plus 2 is equal to 10. It's very simple. Well, the same principle applies in circuits in terms of current. So this simple model with regards to cars entering a point, and we're going to label this point over here. This point, everyone, we're going to call this the junction. The junction over here, where the road splits. This is called the junction. Well, the same idea can be applied to electrical circuits. So over here we have the power supply, and look, we're just going to draw a bulb over here, and look, we're going to draw another one over there, and look over here, we can then finish it off. Well, the similar principle applies. Let's say this is 10 amps going down here, 10 amps, A for amps, don't forget that's the current. So as the 10 amps come in, we're going to say 2 amps take this route over here, and 8 amps will go down here. It's exactly the same principle. Some of you might be saying, why is it that there's more current going down this route over here? It's because obviously this one has less resistance. That's the reason why compared to this one, which will have more resistance over here. But we can talk about that another day. But for today, we're just going to be talking about how the current splits off at the junction. Okay, now from here, this will lead us on to Kirchhoff's first law, which is the following. Kirchhoff's first law. It states that the sum of the current into a junction, yes, the sum of the current going into the junction is equal to the sum of the current out of the junction. So basically that means the total current going into a junction equals the total current leaving the junction, yeah? So we're going to put that down in mathematical symbols if you want. It's going to be this. The sum of the current going into a junction is equal to the sum of the current coming out of the junction. So open bracket at the bottom, at the junction. Yeah, don't forget it's only at the junction it occurs. So look, I've got the sum of the current going in, that's the symbol for the sum, will be equal to the sum of the current coming out. And now look, we'll label it over here. So don't forget, let's call this one I1 and this one is I2. This one is I3. We can connect them with a simple formula. I1 will be equal to I2 plus I3. I2 plus I3 over here in this diagram over here. Happy with that for this one on this side over here. What about for the other one? I'm going to label it. Let's call this one I1. Let's call this one I2. This one is going to be I3 and this one's going to be I4. Well, let's write a formula for this one. So the total current going in is how much? So it will be I1 plus I2. That's the total current going into it. Will be equal to I3 plus I4 over here. There we go, guys. Whoops, I missed off the 1 from here. But as you can see, if I know this rule, which I've put down over here, the sum of the current going in is equal to the sum of the current going out of the junction. That will incorporate the examples I have down at the bottom because I1 goes in, I2 and I3 come out, and this one I1 and I2 go into the junction, I3 and I4 come out of the junction here. So as long as I know this Kirchhoff's first law, the sum of the current going into a junction is equal to the sum of the current going out of the junction, we're fine. Easy stuff. Okay, right, let's test our understanding with the following. Okay, so let's test our understanding with the following example. Find the currents. So here I have an electrical circuit and I'm going to ask you to find the current that will be read off the ammeters, A1, A2 and A3. So let's put it down over here. A1 equals what, A2 equals what, A3 equals what, and A4 will be equal to what? What will they all read? Right, A1, what will it read? Well, look, you know 9 amps comes in. Don't forget, it goes 9 amps goes into the junction over here, And look, 3 amps goes through there. So 3 amps goes through here. So A1 will obviously read 3 amps. Because obviously 3 amps pass through this entire branch. That's still 3 amps as it goes through. All the way through here. Right, A2, you know 3 amps are going to take this route and go through A2. This one will also read 3 amps over here. Right, how much will A3 read? How much will that be? Well, look, we can write down the formula. The sum of the current going in is equal to the sum of the current going out at the junction only. So don't forget, everyone, this is the junction over here. This is the junction over there. That is the junction here. Write this dot over here, that's the junction. So look, we can clearly see that the 9 amps is going into it, yes, and 3 amps goes down this route, so it's 3 amps over here, plus another 3 amps down the A2 route, don't forget. And obviously, it's, you know, some of the current's going down here. So 9 amps goes in and it splits off. So 3 amps through there, 3 amps through there. The bottom one will be how much? How much goes for the other one? We've just got to find X. And obviously, that's going to be 3 amps here. So you're right. This one at the bottom will also be 3 amps. So over here, it will be 3 amps. Excellent. So this one's going to be 3 amps going down the bottom. So therefore, 3 amps goes through the ammeter. The answer is 3 amps here. But notice we've used Kirchhoff's first law to work that out. Yeah, it's very easy. Once you've got it right, you'll be able to get loads of the problems right here. Right, A4. So don't forget A4, what will it read here? So now look, the currents will recombine. So you'll have 3 amps going in, 3 amps going in from here. So that's 3 amps there. We have another 3 amps there. We have another 3 amps there. They all combine 3 amps plus 3 amps plus 3 amps. Obviously, they recombine, everyone, to make the 9 amps once again. So this one is going to be 9 amps over here. Easy stuff. Fantastic. Okay, so we're done for another session. Have a recap right from the top. Right, today's title was Kirchhoff's first law, and we looked at the following. We looked at current in series and parallel circuits. We looked at a simple idea of a road, 10 cars going into a road which splits. 2 cars take this path, 8 cars go down this path. Obviously, because the total cars going into a junction is equal to the total cars coming out. 8 plus 2 is 10, obviously coming in. Then we related that to an electrical circuit, and you can see the same thing here. The current will split off at the junction as well. Easy stuff over here. And then underneath, we started to define Kirchhoff's first law. Kirchhoff's first law states that the sum of the current into a junction is equal to the sum of the current out of the junction. The sum of the current going in is equal to the sum of the current coming out at the junction here. And I had 2 examples which we derived expressions for in terms of I, which I've put down over here. Easy stuff. Then we tested our understanding with the following problem. I got you to actually identify what would the current readings be in each of the ammeters, and we discussed it using Kirchhoff's first law. It's relatively easy, guys. Just make sure you know that the total current going into a junction is equal to the total current going out. And that's it for another session of CeerazzleDazzle Physics. Make sure you hit the like and subscribe button to keep my channel going, and good luck in your studies. Ciao, ciao, and goodbye.